Another part about composition of two functions has to do with figuring out the domain and range. And so if it is a function written out in equation form, if the f and the g or whatever you're composing are both equations, then we're going to use the domain basically of negative infinity to infinity unless it's a rational or a radical function. And for range, we're going to then figure out what are the possible answers, the possible outputs that we could get. Most of the time we do that by using graphing for the range, and we use the domain, we find the domain by either setting the denominator equal to 0 or setting the radicand, which is the part inside the radical, greater than or equal to 0 and working from there. However, if your functions are written out as the two functions are here, where it is written out in itemized list notation. So these are all the values that you could put in for g, these are all the values that you could put in for f. And you'll notice that this first, since we're going to be working on f composed of g, we are writing g first on the left. And that is because g is the one that is going to be going into f. All right, so it's going to be the inner function. So we're going to start by looking at the elements in the domain of g. The elements in the domain of g are 0, 1, 3, 4, 5, and 9. And they form a lot of different ordered pairs. So the element 0, if you notice the arrow, goes to 4. And so that becomes the ordered pair 0, 4. Then 1, 8, 3, 2, 4, 9, 5, 8, and 9, 7. Now these are functions because each of the x values only gets one y value. There are no x's repeating. However, not all of the values in the range of g can go into f. They're not all fitting into the domain of f. So now looking at the domain of f here, all right, we can see that we have 0, 1, 2, 5, 7, 8. Now those values are all function, or f is a function because if you notice all of the arrows only go to one y value. So that's not the issue. However, in order for f and g to be able to be composed into each other, where it's f composed of g, we have to look at g's domain connecting with its range, so that's the ordered pairs we've got written here, and then we look at the domain of f and compare it to the range of g. And so anything that's not in the domain of f can't find a value in the range of f. And so I'm looking at the domain of f here, which I've got circled, and if it's not if the y value I've got written out in my ordered pairs is not contained in there, I'm not going to include that. And so 0 is not one of our values, but 4 here, this 4 in the y value, there is no 4 inside the domain of f. So I don't need that ordered pair at all. There is an 8, so we can use the second one. There is a 2, so we can use 3, 2. There is no 9, so we cannot use 4, 9. There is an 8, and there is a 7. So the next 4 are the only values, the 1, 8, 3, 2, 5, 8, and 9, 7 are the only values that can be plugged into f, and will then have a range value to follow. Now, what are those range values? Well, let's look. So I'm going to go ahead and write out 1, 8 first, and then 8, now going into f, 8 gets translated to 7. Then we're going to have 3, 2, and 3, 2, the 2 goes to 5. So if you notice, all of the ranges in G correspond with the domain in F. Continuing on in this pattern, we're going to have 5, 8, and again 8 is going to go to 7. And we're going to have 9, 7, and 7 connects to 7. As you can see here, we have an arrow from 7 and 8 both going to 7. So 7 to 7, which means that the domain of f composed of g, the domain is all of the first x values. So it'd be 1, 3, 5, and 9. And the range is all of the last y values, which is 5 and 7.